Okay, so we're going to talk about the r squared, r cubed theorem. Now, we've already talked about the similarity ratios and the scale factors a little bit, and you looked at volume last night in your homework. But today we're going to take a look at some other uses of the r squared, r cubed. And I don't think we talked about it in terms of r squared, r cubed. So when we're referring to r, that's just what we already know as the scale factor or the ratio of the linear measurements. Generally, we use r with side length or perimeter, or again, we already talked about any of those linear measurements where the units are just the units themselves, not units squared or units cubed. So lengths, radius, diameter, perimeter, all those we use r for the scale factor or the ratio. When we are talking about r squared, we are talking about area or surface area. Again, those units are square units. And when we're talking about r cubed, you know from last night's video that that is referring to volume. That's when we take that scale factor and we cube it. And we call that r cubed. Another use for r cubed is weight. And we'll take a look at that in today's lesson, how we use r cubed for weight. So let's take a look. So we have these two rectangular prisms, and they're similar. We're being told that. It says the ratios of their vertical edges is 4/7. So in other words, that 4 to 7, that is our R. So that's R. Okay, so we're supposed to use the r squared, r cubed theorem to find the following without knowing the dimensions. So the ratio of the surface areas, in other words, we want r squared. So we're going to take 4/7 and square it. So 4 squared is 16 and 7 squared is 49. So r squared, or the ratio of surface areas, is 16/49. So the next one, finding the ratio of the volumes. Well, we're going to take that ratio, 4/7, and we're going to cube it. So, so r cubed is going to be equal to 4/7 cubed. 4 cubed is 64, and 7 cubed is 343. And that's our ratio of volumes. Next one. Suppose the perimeter of the front face of the large prism is 18 units. Find the perimeter of the front face of the small prism. Well, perimeter, we know we're using r, so we're going to use 4/7, and we're going to set that equal to, we're going to make a proportion here. It says, suppose the perimeter of the front face of the large prism, so large, bigger number, 18 is in the denominator, and x will go in the numerator. So I'll cross multiply that. 7x is equal to 18 times 4, which equals 72. And I'll divide both sides by 7, and I'm going to get x is approximately 10.29. And these are perimeter, so just units. So that would be the perimeter of the front face of the small prism. Okay, let's look at some more. So we have the area of the front face of the large prism. Find the area of the front face of the small prism. Well, we need to go back here. Remember, when we're talking about area, we're looking at r squared. So we're going to use our 16/49 ratio. So 16/49 is equal to, we're going to write a proportion. 15 is the front face area of the large prism, so 15 is in the denominator and x is in the numerator. So I'm going to do 49x is equal to 16 times 15, which is 240, dividing both sides by 49. So dividing by 49 gives us x is approximately 4.9 and these are units squared. So we're talking about area. Okay. Next, so we have the volume of the small prism is 21 cubic units. Find the volume of the large prism. So again, let me go back here a minute. We're looking at our R cubed, which we have down here. We have 64 over 343. So I'm using 64 over 343 is equal to, now, this time we have the volume of the small prism, so 21 is the numerator, and x, I don't know the volume of the large prism. So cross multiplying, 64x is equal to 343 times 21, which is 7,203. And I'll divide both sides by 64. And when I do that, 1,203 divided by 64, I'm getting 112.55, and these are units cubed. We're talking about volume. Okay. Another one. Now we're talking about weight. So weight, remember, that's again using our cube, so we'll continue to use that. Whoops. Don't know what just happened there. We'll continue to use that 60. Try that again. Oh my goodness. Okay, technical difficulties. So we're using that 64 over 343, and we're going to set that equal to, and 212 pounds is the weight of the large prism, so 212 is in the denominator and x is in the numerator. So 343 times x is equal to, I'm going to take 64 times 212, and I get 13,568. And I'm going to divide both sides by 343. And when I do that, I'm getting, divided by 343, 39.56. And this is weight, so we're talking about pounds. So 39.56 pounds. Okay. Next, a couple more examples here. So we say we have the measurements of one animal 4 times the measurements of another animal. Okay, so anytime you have that 4 times bigger or 2 times bigger, 3 times bigger, we know that whatever the original one is, we'll just call that 1. If I'm talking about 4 times bigger, that would be 1 to 4 or 4 to 1. So that's our scale factor or our R. So that's the first part, and then it says that the animals are geometrically similar. So I'm able to do that scale factor because they are geometrically similar. In other words, we're not comparing a bear with a mouse, something like that. So it says how many times greater is the weight of the larger animal. So we're talking about weight. Weight, remember we just looked at, is R cubed. So I'm going to have to take 1/4 and cube it to get R cubed. So when I cube 1, I get 1, and when I cube 4, I get 64. So now that I have my R cubed, my weight ratio, I can see that the larger animal is 64 times that of the smaller, which answers our question. So 64 times greater. Okay. Last example for today. So 2 years ago, Josh bought a puppy that weighed 2 pounds. Since then, it has tripled in length. Notice it's tripled in length, not weight. About how much does the dog weigh now? Okay, so the dog, whatever the dog's length was originally, that doesn't matter. This is similar to that last problem. So we'll just call that 1. And then it tripled in length, so that would be 3. So the ratio for the linear measurement length is R is 1/3. Another way you can think about that is if you want to use x, x was the original length, and then tripled in length would be 3x. So the x's simplify, cancel out, and I'm left with 1/3. So if you're Not sure how we got the 1/3. You can do it that way. X was the length, and then 3x was the new length. Simplifies to 1/3. Okay, so anyway, we're getting R. We're talking about weight. So we know that we're going to need R cubed. So we're going to take 1/3 and cube it. 1 cubed is 1, 3 cubed is 27. So R cubed is 1/27. So now we can set up our proportion. We have our weight ratio, and we know that the dog weighed 2 pounds. That was the small weight before it got bigger. So 2 would be in the numerator, and that means x would be in the denominator. So that means 1 times x, when I cross multiply, is equal to 27 times 2, which is 54. And this was talking about pounds. So the dog now weighs 54 pounds. Okay.